Hi, everyone. Welcome to Boston Python Presentation Night. It's April 20th, 2022. We're going to have a half dozen lightning talks. I think you'll enjoy them. Mike, are you ready to get started?
I'm ready to get started. I'm
Okay,
going
you
to
should be able
start by sharing my screen.
exactly. And we're not timing anything. There's no strict limits here. So tell us your story.
Alrighty, here we go. Well, let's start here. So I'm going to start with two confessions about this presentation. First of all, I didn't use Vega-Lite in Python. My project involved Python. I learned Vega-Lite, this graphing package, and I plan to use it with Python in the future. But so far, I haven't actually done that. It'll be relevant either way, and I think it's a great package. So I want to walk through it either way. Also, second confession, I wanted to do this to show it off in Jupyter Notebook because that's where I ultimately plan to use it. But I couldn't figure out how to get Jupyter Lab to load Vega-Lite. So I'm going to show you the examples here using Visual Studio Code and the Vega editor that's online and some of the other tools that you'll be able to use. Move the camera. That you'll be able to use if if you're going to use this even with Python. So let me start out and tell you what Vega-Lite is. Vega-Lite is a graphing package. It's different from many because it's declarative, not imperative. You don't tell it draw the pie, now color this red. Now you don't tell it how to do the charts. You just tell it what you want the chart to be. And a little like SQL, you don't tell it how to fetch the data. You just tell it what you want to get back. And it follows along this concept of the grammar of graphics that I learned when I was looking at data science in R. When I came over to the Python side of things, I wanted to kind of get back to that. D3 is similar. It uses the grammar of graphics. And generally what I read before I chose Vega-Lite was that Vega is as capable as D3, and Vega-Lite is an easier set of an easier UI or subset of it to get into. And if you somehow exceed the Vega-Lite capabilities, you can compile it right into Vega and you can use the more advanced stuff. Everything I'm going to show you today is just in Vega-Lite. So you define your charts in JSON and it outputs an SVG file. It supports all the kind of basic graph types you would expect, but it also does faceted charts. If you want to have a couple of charts with different y-axes and maybe a grid of different graphs showing related metrics, you can do that. And it also supports interactive charts, and you don't have to code the interactivity, you just define it. So I'll show an example of that as we go along. My project was to log data from HVAC systems, heating, air conditioning, cold water, irrigation water, electric use throughout this building in North Carolina State University. And it's a very modern building, and they have a kiosk that they want people to be able to see these things. And so we were going to collect that data and then graph it. The kiosk is in JavaScript. And so that's why the front end, when I did it in Vega-Lite, is just through JavaScript. But all the data collection I did was in Python. And there was a package called, the devices for this use a different protocol. They use BACnet over UDP. And Python made it very easy through this back0 package to collect that data. So what I wanted to do is avoid the typical approach of coding the graphs into writing code to do the graphs, because I figured we're going to show these to the client. They're going to have changes. We're going to have new ideas as we get more data, and I don't want to keep mucking around in the code. So the idea that the chart specs are in JSON and that they're really powerful, even if I don't use that power on day one, was really appealing to me. And then I can use it in future projects. I don't want to have to learn a new graphing tool every time I step up what I want to do. So that's why I did that. That's why I chose it. If you go to the Vega-Lite chart here, I've got it on screen and their examples.
Mike, if you can you make things bigger
Yeah.
and maybe full screen the windows? We've got some of your desktop, which we don't need to see.
Yeah. Here's a sample chart. So is that
bigger text? Like, yeah.
There we go.
Thank you.
I could just share the window actually, but let me just keep rolling.
Yeah.
So here's how you define the chart. In Python, you're just going to call Vega-Lite and give it a spec like this in JSON, and then it's going to draw the graph for you. The code in Python, which ultimately didn't work for me, but it should have been 2 lines from Vega, import Vega-Lite. Here's the spec for a very simple chart. Here's the name of the data I'm passing in, and that would have done it. Larger.
Yeah, thank you.
There we go. Yeah, in theory, this would have been all I had to do in Jupyter to do graphs, to do these graphs. I don't know why I was setting up a virtual environment, loading packages, and couldn't pull it off for this. But what I wanted to focus on was introducing you to the grammar. Let me, oh, that's not good. Let me just share this window.
Ooh, that's tasty.
Does that help with screen size?
Yes.
Just sharing the one window?
Yes.
Okay. So here's a basic graph. Anybody doing data science has seen this one. Acceleration and cylinders on cars. And what you do is you tell it, where's the source of the data? There's a cars JSON file. You tell it what kind of mark you want, and it's very easy. It's nice. This supports JSON with. You can change the mark type, line to bar to points. So that's pretty straightforward. But then you can also do, and then so you've got the mark for the data. You also have an encoding step, and the encoding is when you say, I want this data on the x-axis or this other data on the y-axis. You can encode data to the axes or the shape of the mark or the color of the mark so that you can get more layers of data on it. In this one, it's showing aggregating the data. If I don't aggregate the data, right, here's the X. Here we're only encoding the cylinders field, and so you just see dots for each of those. Here I don't aggregate it by mean. I just show all of the acceleration values, and you can see all the extra dots there. So changing the encoding and this real-time editor that's available online makes it a pretty sweet way to work with the graphs. What I did was use a couple of tricks like that, but also there's a transform step for the data. I need to screen share back to this other screen now. Whoops. How's the size on that?
Good, thank you.
So I used the transform step to apply filters to data. And so you can set, I'm going to filter by date and then apply a date range to it. Or I can filter by a particular type of data that I want to graph, and I'm not going to plot the others. So that's pretty straightforward. What I did in my code was load the JSON definition of the chart and then access that dictionary and override the values for the filtered date based on what the user selected in the UI. If they selected different floors, I would filter by floor, so I could change that. This way, in the JSON file, I could have definitions that kind of gave me a default chart, and I could play with the graphing and make sure it worked, and leave that in when I checked it into Git, leave those values in there, and then just override them in real time or in production. But that way, at least I had some kind of a graph definition that was working. When I do this in this editor, I can pull up one of my graphs. Here's the spec for it. So I set where to load the data from, how thick the lines are, the height and width, and I just click this to graph it. I don't want it to graph it there. I've got it down here. I'm just going to refresh the graph. It's a bit ugly. We can change stroke width, and I get a redraw immediately. So this gave me a really cool way to mess around with the charts inside my dev environment. You can do it in the online editor, or you can do it here. And then, whoops, I didn't mean to type F there. And then here's the encoding for this chart. So X comes from the date field. You can see I've got my date axis there. I can put the labels at an angle, set the y-axis to be a different thing and to be the source airflow, and color it by the floor. So there's 4 floors in the building, and you can see the airflow like on each floor. In my power chart, I use the transform step to do some calculations. So one of the devices reports back in watt hours, and another device reports back in kilowatt hours. And here I was able to look and see if I have watt hours, perform a calculation on them, or use kilowatt hours. So whichever field had data in it, I would pull in as kilowatts, and then down here, I just put kilowatts on the y-axis. So it's nice that you can kind of do some math on the fly, filtering, math, and all of that on the fly as part of the transformation. And then I've got another example here. This is my month chart. Well, that doesn't look good scaled up like that. But you can do kind of I was able to do a heat chart pretty easily. Just setting the color to be the aggregate of the count, setting the y-axis to be the room temperature. So this is showing me the number of times, or basically how often was the room at 100 degrees, how often was the room at 70 degrees. It gives me kind of a heat chart for each day. And that, there's my, and I wanted to show you a faceted chart. So this chart shows me the 4 floors broken out as separate charts. Not much data in this one for it to look interesting. But I just wanted to show how easy it was to build that chart. Here's the spec for it. So, the transform just filters it. So I'm only getting data that is that has a floor number. I set facet. Each row, that's each of these charts down there, is decided by the floor. So if I had 3 floors, I'd get 3 charts. And then the spec is how I define each chart to be the date and the room temp and the color per floor. So it's very easy, as you start to learn the vocabulary, to get different kinds of charts out of it. Back to my Markdown doc. I wanted to say, take us to this example. I'm going to flip screens one more time. To there. This is just on their first tutorial page, but it shows a simple chart. You might be able to kind of understand how the grammar works now. So the mark is a bar, the encoding is x-axis is time, y-axis is the mean precipitation, and then they expanded the chart, if you go to the next step, to add this rule on it. So they just added another layer, and one layer is the bar chart, and the next layer is the mark, is the rule. And then in the third step, they add the interactivity to this, which is this parameter here based on the brush. Let me open this up in the editor. So if I drag over this, it redraws the ruler based on the highlighted region. And all of that's done without any code outside of the chart definition. And that's why I thought that was a pretty cool trick to have for future projects. I have this Markdown doc. I'll share it out somewhere if you want it. At the end of it, I had a list of resources for their Slack channel and other places where you can get help. That's my talk, my intro.
Okay. There's a question from Greg. Raised his hand.
Yes.
Hi. So I've used D3 a lot to make graphs, and it's a JavaScript-based tool, but I usually have it on a web server where Python is generating the input data, and it has pretty wildly different capabilities. So I'm kind of curious. I mean, they're both high-level tools, but they're wildly different. Are you familiar with D3, and can you say something about what this does better than what D3 does, and what D3 does better than this?
No, because I started down the path of looking at the 2 packages just at a top level, and most of the commentary I read was that Vega-Lite was easier, and it looked like it had plenty of capability for me. So I was like, I'm going down that road. So I guess I'm offering this up as if you haven't already gone down the D3 path, this might be an easier way to go.
That's a perfectly awesome answer. To be honest, there's a lot of situations where I look and there's multiple tools, and I try one and it does the job, and so I don't look further. So smart answer.
It's honest anyway. I see James said there's a Vega integration for D3.js. I don't know what does that mean? I'd love to hear what we mean by an integration.
So my understanding is that because you're declaring what your plot is, it's sort of up to whatever the implementation is to decide what to actually do about that. So you're describing what the data is in the plot. I may be misremembering this, that there's a Vega implementation, but I think I remember hearing that there was something that you could do with it that plugged into the JavaScript. Maybe it wasn't D3, maybe it was just JavaScript in general.
There is another viewing tool, an editor for Vega-Lite, where you kind of put in your parameters using a GUI instead of typing in the JSON, and it generates the JSON for you, and it can even generate the specs that you would feed into Vega. So if you wanted to like just start here and then you really had a lot of other stuff to do, you could. But there's an amazing gallery of charts that you can do in Vega-Lite, and it seems very capable to me. So that's where I went.
All right, thank you. Are there any other questions for Mike? Okay. All right.
Thanks, everybody.
James, are you ready to go?
Yes, I am. I was a little worried that I was gonna get bumped here, but I'm ready to go. Let me share my screen. Okay, are you seeing my screen now, I hope?
Yeah, but your mic is kind of low.
Let me see if I can adjust that really quickly. Oh. Give me one moment. Okay, I can't seem to adjust it, so I'll just speak extra loud. Is that coming through a little bit better, I hope?
A little bit.
A little bit? Give me one more moment. Check one more thing.
Okay. We are being recorded for posterity, so.
How about, I'll tell you what, Ned, how about we skip me and I'll see if I can fix my technical issues on this side, and
Okay.
we'll do that.
All right, we'll come back to you. Patricio, are you ready?
Yes, can you hear me fine?
Sounds great.
Okay, let me share my screen.
Yep.
Can you see my screen?
Yep.
Okay, so hi everybody. Let me get the time here. I will share a quick walkthrough on something that few Python programmers do, that's building a C extension. And I hope that the mystery and whatever idea you have about it, gets away after this. So our goal here is to call the system function in the C standard library that we already have in Python in the OS module. But but we want to call it by importing module that we will build and then just calling it through the module. Okay, we're going to do the building following the process that is in this part of the documentation, in the extending and embedding, and also the Python CAI API. And just one note, there are tutorials in the internet about doing this. Just make sure you don't get an old one, which is for Python 2, because there is a difference and will not work for Python 3. Okay, what will we need to do this that I'm going to show? We need the Python CAPA header files. We need the libpython library and a tool called Python 3 config that will provide us flags for the compiler and linker. And if you're like me in Debian, you just need to install Python 3-dev, and to get the GCC compiler, you install the build essential package. The above will also install these packages that together satisfy the requirements for building. Okay. Now we're going to see a very simple template, because this process, when done like this, is just like a cookbook. And this template is explained in detail in the documentation. I will not go too much in detail, but basically this template has an initialization code at the bottom. The key point is this name, pyinit underscore, and your module name. The Python import mechanism will look for it. If it's not that name, it will not find it. And this function with no parameters will run this function from the CAPA py-module create, which will use this table here, which is the module definition, which in this case refers to a docstring up here, a multi-line docstring, and refers to this table of methods. This table is empty. It only has a sentinel, and we will see in the next step how to fill it. And this space here in the template is where you put the so-called wrapper functions, C functions that will do something and be called by Python. Okay. So let's go down and let's see what will be our first and only wrapper function. We will call it system_graph. We can call it anyways. And this block here is the function. And notice that we have added one line here to register it in the methods array. So this is the name as we see it in Python. And this is the reference to this wrapper in C. And a wrapper function is very simple. It's just 3 steps. One is to receive arguments from Python, and it needs to translate into C values. In this case, it's just a command, and then it's a string. Then do some action. In this case, we call the C function system with command, and then we get the status, the exit code from it, and return it to Python, again, converting it back from C into a Python long object. So it's not too complex. It can get, but not in this example. Okay. Now let's compile by hand. And I'm going to show you the current folder. We have only the C, the module C text that we saw. And we're going to run the compile and the link steps separate. I think it's good to do separate. So if there's an error, you have a better idea what's happening. So now we have the module.so, which is a shared object, a shared library. That's our module. And so let's use it. We import from the notebook, and let's show the help. As you can see, the doc strings are considered here. The first line after the name, subsequent lines in the description of the module. The system function is listed here with its doc string, and very important, you see the reference to the module.so file in the current folder. So let's call the function. We're going to call with ls, the list command. We get the list of files in the current folder. It's called with date to get the current time and date in central daylight savings time. And then let's call just to test foo, which is an unexisting command. And notice how the return value is 0 when there is success, and there's different from 0 in this case. And this message comes from bash. Okay, so we are done with building and testing. So we would say, let's package this so that the other people can install it in their systems. That's called packaging. So we're going to follow the process in the Python packaging user guide in the python.org website. And this, for this recent process, you include a PyProject file that just specifies what are the tools to be used. Setup CFG specifies the metadata for this, let's call it the project. Just I put some data there. And then setup Py is uses setup tools to create an instance of extension. And this way we tell what's our module name, what are the sources file. In this case, it's only one. And you can also specify libraries that you need to link with the module. In this case, we don't have. So we have a little README file with Markdown for GitHub or PyPy if you upload there. And then let's go to build. In this case, we're going to use the build tool that is recommended for today. And we will be with no isolation because otherwise it takes longer. So let's start. There's a lot of text from this tool. this tool makes two things. It builds a source distribution and a wheel. I will explain. Okay, let's go down. So it was successful. Oh, it's not done yet. It's finishing building the wheel. Oops. It's finished. So we have two results. The tar file that contains the source code. So somebody else will have to compile to build the module in their computer. And the wheel is very good because it's a zip file. It contains the module.so file pre-compiled. So other people can just install it and it should work as long as they have the same version of Python. So this is the end of the build process or the packaging process. And here we have the two files in the dist or distribution folder in our current folder. So this is it in a nutshell, very high top level view of this process. And if you want someday to go through it, it's well documented in the website, in the python.org website. Now, I will just finish with mentioning, because I haven't used all these tools, third-party tools that automate this process. We did a simple example for one wrapper. And imagine if you want to do 10, 20, 100 wrappers, it might get tedious and repetitive. So there are very good tools that have different benefits. And I would suggest that if you ever have to write or to access C functions or C++ functions, look at these options and consider what is best for your use case. C types, by the way, is in the standard library and does not require compilation. It sounds very interesting. So you can distribute something without having to compile. Okay, so that's the end. And I don't know if we can have some time for questions.
Thank you, Patricio. I would not have thought that you could get from beginning to end on that topic in that amount of time. So I'm very impressed. Are there questions for Patricio? You have one comment in the chat, which is cool.
Oh, thanks.
Are there questions for Patricio?
Yeah, actually, that was great. I love the demo. Patricio, you compiled for Linux. If I saw the architecture there, it was x86 64. So that was a particular operating system with a particular architecture.
Yes.
So if I wanted to use, if I follow correctly, if I wanted to use that library like on my Mac, I would need to compile it myself using the source distribution. Do you have any thoughts on how to like build and distribute more, I guess, more wheels for other architectures? Did you look into that at all?
No, I'm not familiar with macOS, but the instructions that are in the website in python.org for packaging and distributing binary or compile extensions, there are explanations for Mac. So maybe you want to look there if there's something special. And I can imagine that a famous project will provide by themselves, they will be compiling for different architectures and uploading to some central place so people can just unload pre-compiled.
Right.
Mm-hmm.
There's a project
Cool.
called CI Build Wheel, which is designed to help library maintainers solve that problem by providing Docker-based compilation of wheels onto a bunch of platforms. Works great.
Okay.
In the chat, it says +1, Python C extensions are quite arcane, and this was a very nice explanation and walkthrough of this.
Okay.
Any other questions for Patricio? All right. Thank you, Patricio.
Thank you. I appreciate it. Thanks.
James, what do we think?
How am I sounding now, Ned?
Better. It's
Am I
louder at
sounding-
least. There's a little
Sounding better at loud at least. I apologize for the quality. I don't have a decent microphone on me, so making do with the array I have here. But I'm ready
All right,
to
let's
go.
try it.
Okay. Share my screen here. Let's see. Are you seeing my slides now?
Yep, from user to configure.
Wonderful. Okay, so hello, I am James. I am a member here at Boston Python. I do Python for a company in Boston called Neurala. We do computer vision, but I just want to talk today, share a few thoughts on going from a user of a library to the contributor. So there's a lot of people say just, oh, let's contribute to open source, like just do it. But what does that process actually look like? I've made a few contributions lately that I want to talk about because I think they are a pretty good cross-section of the different types of contributions that you can make. So let me just jump right in with the most recent one, actually, which was PyInstaller. If you're not familiar with PyInstaller, it is a way to package up your Python programs. So if you want to make like an installer for, hence the name PyInstaller, an installer for Mac, Windows, or Mac OS, Linux, or Windows. PyInstaller could be really useful. And it has actually two different modes of operation. Either you will feed it a .py and it figures out what it needs to package the dependencies of that .py, all the libraries that it depends on, into the final package. Or you can actually feed it what's called a spec file. And if you don't feed it a spec file, it will make one for you. So that's sort of the setup for what this was. I was doing this for a work purpose. We use PyInstaller to deploy to Windows. And what I discovered is that sometimes there are some arguments to PyInstaller that if you invoke it just right, it actually just ignores those. They don't do anything at all. And that was pretty frustrating. That actually burnt up a good day or two trying to figure out like what's going on. I'm passing these arguments and nothing's happening. And it just turns out that they're ignored. Specifically, these are the arguments that if you are making, you need to make a spec file. So you feed PyInstaller just a py file. If you feed it a spec file, it's going to ignore any of the arguments that influence when that spec file is generated. So the very first step is, once I figured out this was going, I said, well, that's kind of annoying. And I wish I had known that, that was happening. I wish I got a warning or an error. So first I just submitted a bug report saying, hey, here's a way to report an error just with this. It was the one-line sort of thing. And I got a response back pretty quickly from the maintainer. This is the first step, I think, in most contributions, just making somebody aware. At this point, I really didn't intend to do anything to PyInstaller. I just figured, hey, I'll let them know that this is a problem that maybe somebody should address. When I got a response back.
So before you move on, I just want to point out that writing a good bug report that explains the situation and makes very clear what is wrong without any anger or malice, that itself is a contribution. You have made a contribution to that project.
Absolutely. And I think don't be in too much of a rush to try and fix a problem. Just reporting it and providing all of the information necessary for someone to come along and fix it can be a huge contribution. That's a great point, Ned. Thank you for pointing it out, because that's where I was at this point with PyInstaller. I did not intend to do any changes to PyInstaller. I just said, hey, I would love it if this was an error or a warning so that whoever is me next time and runs into this issue just gets an error thrown in their face saying, hey, that argument doesn't make any sense in the mode that you're trying to run PyInstaller. So I got a response back pretty quickly. I think I submitted it a day or two before this response, and you can see it's linking to another PR here, 6460, and that would have sorted it, but I doubt we'll ever go through with that one. And that was kind of a bummer because I looked through at what that was is changing over their command line from they use argparse, and they were going to change to click, a different command line library. Unfortunately, he also told me we're not going to do that. So I said, darn, this isn't going to get fixed at all unless I come up with a way. So okay, at this point, now I've gone from wanting to do a report to, gee, I really wish that this could get fixed. And I also see what the friction is of here's why it's not getting fixed. Here's what's not going to happen. It was a pretty elaborate PR, this other one that he's linking to. So at this point, it's like, okay, I want to get in there and see how can we make this change in a way that's less disruptive than this other PR. So the first step in doing that was to dig in and figure out what's going on under the hood in PyInstaller. I promise these are the only charts I have in this. It's a really simple flow inside of PyInstaller. It says, what did the user pass on the command line? Did they give us a spec file, this .spec? If they didn't give us one, we better make one for them. And if they didn't, we just go straight to creating the package and then go on to do other things. So my change was just about trying to make the picture look like this. If we did get a .spec file, but we got arguments that were about make spec, that's nonsense because we're never going to get into make spec. So we don't need those arguments. And at that point in the program, we absolutely know the user has asked us for nonsense. We should give them a warning or an error. Actually, I was originally suggested a warning and they said, if I back up here to this response, if we're going to start slapping checks in, I'd rather that they were errors. I was a little bit too timid originally. I had put in a warning rather than an error. And the maintainer gave me some really good feedback. And that's the other part of this submit a report and have open that conversation, because the maintainers are always going to be able to give you really good feedback on what the best thing is to do. So if we get that nonsense, we issue a nice error. This has been merged. And if you're a PyInstaller user, I think it starts in PyInstaller 5 is when that change takes effect. So the takeaways from, if I can get my slides to advance here, maybe. Uh-oh, what's going on here? Okay. Scratch your own itches. I discovered this as a work bug. This wasn't something that I was like, I'm going to make an open source contribution today. It was something that cropped up at work, but I decided, hey, I'll tell them about it. And then it turned into a fix. I originally feared that my solution would be rejected. I tried not to talk about the details too much other than just that figure to show the thought process behind it. But it got a little complicated at a certain point, and I thought, oh, geez, this is looking like it's kind of complicated. And the maintainers might say, no, thank you. It's too complicated, because I was trying to avoid that from that other PR. But there's a piece of advice that I really love from the Wikipedia community, and it's be bold. In particular, if you're working on GitHub or anything else that's version control, the version control is there to have your back. You can't really break things, and even if they get broken, you can always go back. So I adopt that advice and say, people, make the changes. The worst thing anybody can say is no, or if it's broken, you can always go backwards. So make your changes, make them bold. Okay, so a second story. In PIP, I am a member of a different Python community on IRC, libera.chat. And a user came in asking this kind of weird question, like, hey, when I run pip in verbose mode with this -v flag, and I'm cloning from Git, you can have Git do this for you. It will clone from some sort of version control. It's not giving me any feedback of Git. The verbosity of Git wasn't actually being turned up. Git was still being run in quiet mode. And the problem they were having after another, this person had their version of my story of at work, they spent a day or 2 days trying to figure out what was going on. It was a problem in the actual Git clone step. So not a problem due to Git, but a problem due to Git. And I think it was a network problem of some sort. And they were like, why isn't Pip turning up the verbosity of Git? And so it was a good question. I got interested in it. There was a terrible hacky solution that I won't even talk about more than just to say it exists, because nobody should do it. But in doing that, I kind of got interested. Is there a better way to do this? As it turned out, there was, but it required some kind of plumbing changes. I called them here. Basically, the verbosity needs to be passed all the way down to where you call the git command. And they were just saying, oh, we'll always do git clone or whatever version control software. It'll always be quiet. So I had to figure out, how do we get that verbosity information down there? And here's where I made a mistake in this PR. I opened a PR as a work in progress, as a draft, saying, well, I don't know if I did the plumbing changes quite right. I wasn't bold. And we'll see if somebody comes along and cleans this up. It was eventually merged, and now if you pass dash V to pip, it will turn this up. It was a pretty simple little thing once you got the verbosity information down there to, instead of making it quiet, just go ahead and turn the quietness off. But as I said, making that a work in progress was probably a mistake. I wasn't being bold. And it's one more thing a maintainer has to do if you're looking for feedback that is just because you weren't being bold. I'm not saying don't ask maintainers questions. It's a great thing to do. But in my case, I had sort of done part of the work and then waited for someone to come along. And I even screenshotted here. You can see, hey, is this still work in progress? I'm waiting for this to be ready before I take a look. But clearly they took a look at this PR to write this comment. So kind of they had to come back around again to look at it again. So that's just, again, be bold. Something happened to my slides here. I just want to wrap up with documentation is actually probably the best, to save the best for last, in my opinion, because docs are a fantastic way to contribute to literally any project is going to have documentation, and everybody hates writing documentation. It's always something that you feel behind on. And you as a user are going to have a unique perspective on it. Sometimes when you're working on something, you kind of lose track of what people do or don't know, your users. So if you're reading documentation and you're confused, I guarantee you someone else reading that documentation is confused about exactly the same thing. It's one of those things that happens. So if you spot something that can be improved or clarified or reworded, that's generally going to be welcomed. And I will say that Python itself has lots of this, especially in the standard library. The standard modules just have they're written by lots of different people at lots of different times. There's 20 years of history or so that spans. So you'll find plenty of stuff in there, and that I'm not saying that as a hypothetical thing. This is one that I've made. Is I was reading you can look at the grammar of the Python language. I don't want to get into those details, but this little bit that I highlighted down here, the syntax was just kind of plopped on the page, and I was looking at that and I said, I have no idea what this means because it wasn't a familiar thing. And then eventually I found it's in one of these PEPs, and I said, well, that should probably be on the grammar page. Let's go ahead and put that. So that little bit in red was something that I was confused about. It took me a while to figure it out. Once I did, I said, hey, why don't we put it in there for the next person who's confused? And it was easy. It was one of the only things I've contributed to Python itself. As another example, something from NumPy. This wasn't even like a confusion thing, or maybe it may have come from a question someone asked. Isn't that for 1D arrays only when you use random choice in NumPy? The doc said, hey, that's for a 1D array, but it actually works for an array of any size. So that was an easy fix, just take out the 1D. But there's lots of little stuff in this, especially in libraries that are large or have been around for a long time. You'll find just tons and tons of this stuff. I know another example in Python is there was, I think, an overflow error versus a recursion error, and the error had changed at some point, but the person who had made the change hadn't figured out every single place that the error was talked about or something. So in the documentation, it said, this will produce such and such error, but it actually produced the other one. So that was an easy fix, just change it to be the correct one. Wrapping all of that up, I didn't want to brag about PRs, but I wanted to kind of get a cross section of there are always things that can be improved in pretty much any software, so keep your eyes peeled. That's the number one thing. If you're a user and you run into something, a good bug report is always a good place to start, or a feature request. Give the maintainers what they need to work with that. If you are going to make changes, be bold. And I should probably have bolded and underlined that, because really, be bold. You won't break anything, I promise. And it's one less thing that needs to be kind of iterated on. You can always think of it as the start of a conversation. You can always come back around and make more changes. And that's part of the purpose of collaborative development, working on software together, is that you can say, here's what I thought, and be bold. And then the reviewers can be bold in their remarks to you and say, well, here's what I think you should change. And be easy to work with. This is something that I don't see people talk about a lot in open source, but a lot of it comes down to just give everybody what they need to work with if you're working with other people, and be nice. Be nice is unfortunately one that's actually really low hanging fruit. People aren't always nice. So that would be just a general piece of advice. But in particular, I would recommend the 2 PRs that I showed off, the PyInstaller and pip. Those were pretty long processes. It took a couple of months for the pip one, and then the other one I think was slightly faster than that. But as your PR is open, as your potential contribution is open, other changes will be happening to the software underneath your feet. And so you're going to create merge conflicts at a certain point. And that's one more thing that a maintainer is going to have to do if they come and see, oh, that PR is going to have merge conflicts. We can't merge that yet. Or someone is going to have to go and resolve those. So if you have a PR open to a project, I would make sure that if something happens and there's going to be a merge conflict and a maintainer can't come along and just click the green button and pull your changes in, go ahead and update your PR. That maybe is good fodder for its own talk someday. But the less stuff that a maintainer has to do to get your changes in, I promise you will help you get your changes in easier. That's actually the end of my slides. So thank you for listening to me blab about things that I contributed recently, and I hope that it was helpful to someone.
All right, thank you, James. And I'll just give a bit more color to be bold, which is you have to pair it with be nice. Some people will write very, very bold issues, which are actually angry, and that's not the right kind of bold. So go in with a collaborative mindset.
Absolutely.
And we have a comment in the chat. Lots of projects now have a good first issue tag on the issues section, which is a great filter to find issues to start with. So
yeah, absolutely. And there are some events that are very geared towards people who haven't made a PR or done something of that nature before. Hacktoberfest is one that's run by DigitalOcean in October, but there are probably other ones. I'm just forgetting the name of them. There's a fun fact that I forgot to put into these slides, or didn't put into these slides. It was somebody who was involved with the Python Software Foundation. I want to say it was Jessica McKellar, but I can't be sure that it was her. Anyway, I believe this person, in a role of importance in the Python Software Foundation, and during a keynote at a PyCon said, one of my first contributions was documentation to the Twisted project. So really, I want to emphasize the docs being at the end of this was very intentional. That is a fantastic way to get started with things because your force multiplying effort is the highest when you're contributing to docs because other developers are going to be reading it. So you kind of get credit for all of the stuff that you helped with if you contribute that way.
That was Jessica McKellar.
Okay, wonderful.
Glenn's got his hand up. Glenn,
yeah, I was just curious because I'm going to get to participate in sprints out at PyCon here next week. How does that interact with this type of a contribution?
I guess that's part of what I didn't capture in what I tried to get with a cross section here. But the idea, so to back up a second, what is a sprint for those who maybe have heard that term and don't quite know what it means? The idea is we're going to get some number of people and we're going to focus on some goal in a project and sprint towards that goal. This is particularly common at conferences. The term is used for kind of a few different meanings, but I saw PyCon sprints were mentioned in the chat, and Glenn, you mentioned, I think PyCon as well. At conferences, it's particularly popular for a particular library to say, hey, if you're interested in working on Matplotlib or NumPy or whatever library it is, we're going to be at PyCon and we're going to have a little corner where we're going to be working on improving error messages or whatever feature it is in that library. I would say the be bold is probably less applicable because you're going to be working much more closely with those people. There's going to be less of that communication friction of I have to send this message out into the internet and wait weeks or days or however long it's going to be for somebody to see that and respond to it, and then for me to check for that response. When it's someone just across the table, you can kind of just say, hey, I need your feedback on this, and then have that conversation face to face. But I would say the other advice here, I think, still applies to that. A sprint is usually much more focused, so it's usually less generating contribution notions and more, here's what we want to work on, here's a list of feature requests or bug reports or whatever it is, and we're just gonna kind of go down that list and try to get to a milestone.
And I'll just
Hopefully
point
answers
out,
your
since we were
question.
discussing Scrum before the event got started, that the word sprint is used in a slightly different sense when you're talking about, for instance, the PyCon sprints. It's really that you're at a conference with people from around the world, and it's a unique face-to-face opportunity to get some very high-intensity collaboration done. And so it truly is a sprint. The problem with the use of sprint and agile is it's not a sprint because you do it over and over again forever. That's a marathon. In this case, it really is a sprint. You're going to work very, very hard for just a few days together. Brian's got his hand up.
Brian has his hand up, yeah.
Sorry.
Yeah, James, that was a great overview. I love that. I'll give another amplification for contributing to docs. It's also a great way to get it's kind of be your gateway into a larger project or into a code contribution into a project later on, because you can get, it's a way to sort of a lower stakes way to introduce yourself to maintainers, kind of learn what the processes are before contributing code. I love the emphasis on filing a bug report first, specifically like doing that before filing a PR. Like you might know the fix, but before you kind of invest the time and making a bold PR, like get some kind of buy-in for the change you want to make, unless it's truly just like a trivial thing and it's easier to sort of explain just with a PR. And I guess one more kind of addendum to being bold is being bold, but still keeping it scoped. Add one thing, change one thing, make one thing better. James, you kind of touched on this with the PR that didn't get merged. That the thing that was fixing the thing you wanted was also like sounded like it was doing a bunch of other stuff, and those kinds of things are best usually split out into multiple PRs. So like you might be working on a bit of code and think like, it's like, here's a change, and gosh, it'd be really nice to refactor all of this and make it better and easier to understand. But that PR is going to sit there for a long time if it ever gets merged. You can follow up the refactor, the reformat in a later step. So
yeah, I would say those are great points, and that last one kind of plugs into, I think, being easy to work with. While you want to be bold and you want to change things, you also want to make it easy for the maintainers to click the green button and pull in the changes. And it's really, really hard to do that when you do lots of things. To clarify, both of the PRs that I talked about in this were merged. I was kind of scared about the PyInstaller one. You were right though about what you were hearing there. I can expand on that just a little bit. I ended up writing a subclass of the argparse argument parser and kind of added sort of this like way to tag options so that you can say, oh, don't let any of the options in this group through. And I was a little worried about the scope creep kind of thing of, is this doing too much? Is this too big of a way to fix this problem? But in the end, I deferred to being bold and saying like, okay, if the maintainers think that this should be cut back, I'm going to count on them to cut me back, to say, hey, this is a little complicated, this is a little much. And I think I even said something in the PR of, hey, if this needs to be whittled back a little bit, maybe this got a little bit out of hand and I can pull this back some. But great points.
Yeah, and just to clarify, I wasn't suggesting that your PRs were out of scope. There was the first one where that first issue you pointed out where the maintainer responded, it's like, this PR would fix it, yes. But it was like trying to go from argparse to click and all of that stuff. And, yeah.
And so that issue actually, I think that was the purpose of that issue, and it was looked on very favorably, but it was also kind of just digging up the entire foundations of the command line interface and switching, and that's a really, really big commitment on the part of a project, especially a project like PyInstaller, where it's part of the bedrock for so many projects. And similarly, I guess for pip, although the pip changes I talked about were not as big a deal. So there's a real tendency to stay away from that. But once I saw that, once the once that maintainer had said, oh yeah, we sort of have a fix on deck for this, but it's definitely not going in, or that was my read on it, I said, okay, well, maybe there's another way to do this that meets your needs as the maintainer. You know, I was sort of reading between the lines and saying, that's a little too complicated. Is there a simpler way to do that? Great remarks.
All right. Thank you, James.
Thank you.
Glenn, is that on
Greg?
Greg, yes, Greg. Sorry, Greg. Are you ready?
No problem. Let me share my screen here. With luck, this will actually work. Okay. Do you see my first slide?
Yes, astronomy potpourri.
Okay. So, hi, my name's Greg, and I do a lot of Python for a living. And I'm an astronomer, and so our community does a lot of high performance computing and data science, and almost all of that is actually done in Python. And almost everything that we do needs to be able to run on both somebody's laptop and also all of our supercomputing clusters, which are frequently very weird and different from one another. And my personal job involves turning many petabytes of data into a gigabyte or two. So in the astronomy community, Python has become sort of the normal language that everybody uses. And if not Python, if you've got C and C++ and Fortran code, frequently that's either encapsulated in Python, or if it's not encapsulated, they're in the middle of the data pipeline. There are places where the data can be output in a standard format that you can manipulate it in Python and then return it to the rest of the pipeline. And this is not that different from the normal thing that data science does. So we use a lot of the same tools that everybody uses, Pandas, PyTorch, blah, blah, blah. All of these things are actually other languages encapsulated within Python for ease of use. And the coolest thing about my job is that it involves a lot of inspiring work. So this is our telescope array that we're currently using. So we don't use the red ones, but we use all the yellow ones. And then this year in 2010, we used the green one in Noema, so you can the upper right. That's in the French Alps. So we go from Tula Air Base in Greenland down to the South Pole, and from east to west. And the most annoying thing about this, by the way, is that the South Pole telescope is on a freaking glacier, and it slides between years. And one weird thing about the kind of astronomy that we do is that we need to know the location of every telescope to within a millimeter. And if we don't know, we can solve for it. And so we watch that glacier slide on the South Pole every year. And then the other weirdness is, well, so it's the South Pole, right? So during the South Pole winter, you can't fly a plane in for 9 freaking months. And there's no satellite coverage to speak of. It's slow. And so as a result, we have to wait until the spring arrives so we can actually fly the data back to civilization. But this is what we get to see. So this is the black hole in the middle of the galaxy M87. And that dark spot in the middle is the event horizon of a black hole. So you might have seen this in April 2019. And by the way, we also observe in polarized information. So this tells you what the magnetic fields are in that same black hole. And so this was released last year. And if you hang on, not too long from now, you might see some new press releases from us with new images of other stuff.
We're not getting a sneak peek?
You are not. Oh my God, they would shoot me. So when you're involved in a project like this, you get tempted to write infrastructure software. And there's a lot of infrastructure software, out there, right? If you're trying to solve a problem, you want to solve it in a generic way. And if somebody else has already written software, you should use it. And so here's some examples in the Python community: NumPy, Pandas, and Ray. Ray is a distributed computing protocol that probably you folks have not heard much of, but it's used a lot in the cloud and machine learning community. So my colleagues in astronomy have this computation pattern, and all the images that I just showed, literally the way we figured out how to be confident that that thing is a ring and not something else, right? It's not a point source. It's not a double point source. It's not a disk. The hole is really there. That involved hundreds of thousands of simulations where we would take fake data of, for example, a disk, and we'd run it through our algorithm, and we would make sure that it doesn't accidentally show up as something with a hole in the middle. So that involves hundreds of thousands of parameter combinations. And so I decided I'm going to write infrastructure software that does this. So this is harder than it looks. So here's what my thing looks like, right? So you initialize the parameter survey, and you create some parameter sets, and you run a map function, and there's that worker function that does something, and you get some results out. And all of this looks really simple, but it's harder than it looks, because you have to do this in a way that's sort of future-proof. The minute that the second person uses your clever software, you discover that you didn't quite design it right. And about the time that the 1000th person uses your software, you discover that you really designed it wrong. And this is a very painful learning process. So I'm here to report on some of the pain. So here's some advice if you ever want to write software like this, and a lot of people do. So the first piece of advice is that don't invent a new interface if you don't have to. And so the interface that I showed you is somewhat like Python's multi-processing pool, which if you're computing on a laptop or a server with a bunch of cores, the Python multiprocessing package works really great. And you can get a perfect linear speed up without even trying hard. And so mimic that if you can, and my interface does. My second piece of advice is to use it yourself first, because you're going to have gotten things wrong. And so the first couple of times, you really want to go to your colleague and say, hey, you should use my new interface. And oh, by the way, I'll make your code do it, and then I'll come back to you when it works. Because after you've fallen on your face a couple times in the middle of getting this to work, at least you didn't have to tell your colleague about it, until you're done. So eventually you fixed your software, it works, you go back to your colleague and you're like, hey, I successfully converted your software to use my thing. And life is good. And so the third piece of advice is go that extra mile. So even after that first 2 or 3 colleagues, whenever somebody comes back to you and says, I tried to use your thing and it didn't work, then, if they can't get it to work, that means the debugging tools aren't good enough. Probably if they tried and the debugging tools were great, they would have solved the problem, and they wouldn't have even written you that complaint. So whenever somebody comes to you with a complaint, go and debug it yourself. Because there's lots of things that are actually really hard. And so the particular things in this particular interface, so first, when you use too much memory in Linux, it's really not that obvious what's going on. And there are actually many frameworks that are used for distributed computing in Linux that fail to do this correctly. And part of that is because Linux actually doesn't have a way to really police the memory usage of an individual process. And this is sad, but it is the way it is. And no matter how much you want to be bold about it, you're probably not going to solve that problem, because about 20,000 people have tried to go out and be bold and solve that problem, and it doesn't work. So you need to mitigate it. And a lot of the existing packages for distributed computing in Linux don't mitigate it very much. The second suggestion is, so there's always this ex post facto thing that I ran some really big computation, and after 5 days, it failed in some mysterious way. And oh my God, do I need to run it again with debugging turned on in order to find out what happened? No, that's not the best idea, because that's 5 days. And so the trick I used was I made a hidden log file that actually records debugging information at a higher level than you asked for. And so when your thing crashes, you can go and look at the hidden log file and find out what went wrong that you didn't ask it to diagnose, but it carefully saved this information for you, and that's an awesome thing. The third suggestion is, many things about log files are very difficult if you've got a whole bunch of chatter mixed in with everything else. That it can be very difficult to figure out what the failures are compared to the other stuff. And in this particular case, what I did was I made sure the hidden log file didn't have any of this extraneous information and only the most important stuff. So there's a straightforward way to solve that problem. And then finally, by looking at the problems your users had, if you don't have enough debugging features in the thing that you wrote, you'll discover pretty quickly what they are, and then you should add them. And so that actually goes back to my first point, that the most difficult thing that my users have had to debug is using too much memory. These are astronomers, and they, while they know how to figure out how much memory their code uses, they usually think about that way after they have a problem. They don't think about it in advance very much. And so it's very important to have a debugging feature that points out front and center, hey, you're using way more memory than you thought. You can have a nice Shakespearean soliloquy. Oh my God, too much memory is being used. I'm going to die soon. And you have to do that in advance, because once it actually starts dying, life is terrible, and it won't even necessarily have the ability to print any kind of debugging message. So by the way, my organization that I work for, the Center for Astrophysics, is hiring Python people. And here are some pros and cons as to why you might or might not want to apply to us. And so there's a lot of cool work to be done. The pay is low. The HR human resources process is pretty terrible. But if you want to come to work for us, let me know and I'll help to guide you through it. So this is my last slide. If only I could figure out how to share my screen. There we go.
All right. Thank you, Greg. Any questions for Greg? I have so many questions, but I don't know how many of them are actually on topic. Any questions for Greg?
So there's a question that in the chat, winter over at the South Pole. So 1/3 of the people who winter over at the South Pole are astronomers. But yes, for 9 months. I mainly put that in there as a joke.
That's pretty serious.
It is.
Any other questions? I agree with you about the debugging tools. I maintain coverage.py, and there's a shockingly high fraction of the code in the package is there just to provide debugging information for when things go wrong.
Yeah, I must say that for coverage in particular, one of the most annoying things with dealing with continuous integration systems is getting coverage to work in arbitrary situations. And it's not on the coverage code itself, it's in the tools above it that report in on what the coverage is for, please combine these 10 runs together to tell me the coverage of my entire package in these 10 circumstances. And wow, but I think I spent 2 days working that out in the Travis era, and then I managed to go to Azure and then GitHub Actions, and I didn't to do the 2 days of work again. So it was not that bad of an experience. It was painful, but at least it was a repeatable lesson.
Well, hit me up on Slack the next time it happens, and maybe we can find a way to smooth that path a bit. James has his hand up.
Yeah, great presentation, Greg. I wanted to ask you about, you mentioned memory usage on Linux. We've run into this a little bit at my employer, and I've looked at some solutions to it. There's like resource limiting and there's C groups. Have you tried things like that? I'm just curious what sort of approaches you've tried that Linux provides that are less than satisfactory, because I've also found what's on offer kind of less than I want.
So I haven't experimented that much. So, in my imagination, I would be, hey, user Greg can't use more than 4 gigabytes, or my process tree can't use more than 4 gigabytes. And both of those are impossible. The only thing that works is this C group has less than 4 gigabytes. And so that works great for Docker, and it doesn't work, well for anything else in a container. And so literally what I do is in my current code, I figure out what I think is reasonable for the number of, like, literally, you know, how many gigabytes is reasonable divided by the number of processes. And if that gets to be too high and I get over, you know, 90% of that, then I start doing the Shakespearean soliloquy thing in the log file. And I hope that eventually after I die, because if you're really using too much memory, usually it goes pretty quickly too far. And then hope that the user looks on the log file and sees the soliloquy.
Mike, you've got your hand up.
Yeah, I have a question about Greg. Is really interesting presentation. And my question is about the log files. So you are you saying you keep two logs? One that's kind of the user log that gives them easier things to debug, tells them how they set it up, and then you've got another one running that's just super verbose. Do you automatically rotate that, or is it just the last run?
The trick is that the other one that's running, it's a higher verbosity, but it only has a system verbosity. It leaves out all the user verbosity. And so as a result, it's small because I get to control how much my system outputs. And so I don't rotate them because they're all less than a megabyte. And disks are big these days.
Okay.
But indeed, that is that is an important thing, right? Are they too large or not? And then the other thing is that as far as the verbosity goes, is I made an additional point about emphasizing the actual failures. And so if I included all of the user crap in that file, or too many, you know, informational messages in that file, both of these things would make it very verbose and hard to spot the actual errors. And so there's a balance to this, and you got to try to hit it as best you can.
Yeah. Thank you.
So John's got his hand up, and then we should make sure to get to the last two talks before we run out of time.
Then let's not pursue this any further because I had further thoughts on logging, but we could always take it to the Slack.
Logging, good. Daniel, are you there?
Yes, I am ready to present. Yeah. Sure. Okay. Do you see my
Yes.
Python slides?
Yes, we've got
Okay.
some nice Helvetica on the screen.
Nice. So today I'm going to present about teaching Python to middle schoolers. I'm currently a high school student at Buckingham Brown Nichols. It's a school in Cambridge. But after I will be attending Dartmouth, I'm possibly thinking about taking a gap year. For my programming history, I've done a little bit of programming in like elementary school, middle school, with HTML and then Lego Mindstorms, which are very fun. And if you have kids, I recommend you introduce them to Lego Mindstorms. And then I sort of got back into it in the 8th grade with Python. I wanted to work on an app. I forget what it was, but I really wanted to learn to program again, and Python just where I picked up. And recently I've done like scraping, web programming, app development, data visualization, and analysis. And in terms of like where I've been doing stuff, I've been doing some independent projects, but I've also been spending a lot of time with the Free Software Foundation. Part of my programming journey is also teaching, which I've been doing since 9th grade. And I think it's a really important part of like how I've been programming and my path to now. I also want to say, take what I say with a grain of salt. I'm not exactly an expert on, I don't have a degree in teaching, but I've just done enough and I feel like I have some cool takeaways. So why do I like teaching? Why do I do it? For me, I think the biggest thing is seeing that epiphany moment. I think it's like a feeling of seeing somebody understand the topic that you understand. That's very gratifying. It's something that I don't feel is replicated in any other field. Even when I'm like working on some code, finally finish debugging something, there's nothing really like seeing somebody else achieve that moment, because it's sort of a function of what you've done, and sort of doing it for somebody else is always feels really great. The other thing I like is forming connections with students and other teachers, both about the academics themselves and seeing their new perspectives on it, and also just personally. But I also believe that teaching is the ultimate test of personal knowledge. And if you can explain something, especially at a very simple level, it means that you know it very well. And that's something I really, that's why I try to teach as much as I can, because I feel like it's very important to me for my own knowledge. And then I like that teaching allows you to sort of not have to extremely specialize in one particular field or like subdiscipline. I feel like that's that's not true for everybody, but to me, I can learn like a library that I want to teach for Python, and then I can learn some Django if I want to teach web programming to somebody else, and I can be able to spit out. The other thing is more practical, is that it can be done pretty much part-time if you want it to be. I've worked with people who have done it as when they were getting PhDs, when they were working a lot of different backgrounds going to teaching, especially non-like formal public education, high school, middle school settings. So where did I start teaching? I started teaching at Beaverworks. Beaverworks is the on-campus component of Lincoln Labs, and Lincoln Labs is a collaboration between MIT and the Department of Defense, where they do a lot of research. It came out of the government investing a lot of money for research at the MIT during World War II, and then sort of they created this for that. They run a program for incoming high school seniors called the Beaverworks Summer Institute. It's been running since around 2014, 2015, I think. And the flagship and first course is called Autonomous Race Car. Basically, this course teaches students Python. There's a little bit of a pre-course that goes into the ultimate selection process, where they learn Python, learn some OpenCV. And then for 4 weeks during the summer, they build autonomous sort of like vehicles. The vehicles are built by the staff, and they like there's a bunch of different tracks that they go to, and it's basically 4 weeks of machine learning and controls and a lot of different stuff. But it's all very interesting. And basically what I did is I and the other people I worked with converted the course to a format accessible to middle school students. The team I worked with had graduate students, postdocs, some education professionals, and it was really interesting to work with them. Basically, there's 2 sessions. The first session was held at the Roxbury Innovation Center for children who go to, mainly children who go to school in Roxbury for middle schoolers. There's 4 classes, and those ran for 4 weekends. So pretty short overall, but still 16 hours is a fair amount of time. We didn't expect any pre-work for them, but they still learned Python. And then the last day was focused on a little bit of teaching the actual like autonomous vehicle portion. And then the second session was like the main one. The spring one was more of a trial for that. It was 4 weeks of all-day classes for middle schoolers there's a lot of different backgrounds around the Boston area. This was in 2019, so it was in person. And for the actual like material, how we delivered it, it was a lot of in-person lecturing. And each lecture, such session, had Jupyter notebook that was attached to, that had some information, had a lot of exercises, it had notes, and there's spaces for the students to take their own notes. Forgive my misspelling of Jupyter there. So what I really took away from Beaverworks is that to design good educational material, you have to imagine yourself as a new learner of that material. And also that designing and teaching with people who are just doing the material for the first time can be really valuable for their perspective. This is something I heard a lot echoed from the people I was working with. And also when I was doing the first run of a lesson, having a peer like look over it and sort of try doing it themselves to figure out where they get stuck was really valuable. Sometimes when we were designing lectures, especially when we were getting more into the autonomous vehicle portion and beyond Python, we sometimes assumed a little bit too much knowledge for the students. And so it's really important to really see if all the knowledge you need is in the information. While there's definitely value in teaching students how to Google and all of that kind of stuff, especially for middle schoolers, they don't have the skills and patience for that. And it's really important to give them a streamlined process that it doesn't have to carry them exactly from A to B, but it shouldn't allow them to fall into like what I like to call learning ditch, where they can't get out where they're stuck. That can be very harmful to the learning process, especially for younger students. Something I also learned is that challenges teach more than teaching. This is a pretty common theme I hear echoed across the software industry and beyond in education. It's that you really have to do projects and exercises, because just listening and reading won't reinforce that knowledge into your brain. You have to give that contextual comprehension to really allow students to soak in what you tell them. Like with Python, it's at the end of the day, they don't really care what middle schoolers don't exactly care about data types and lists and loops. They sort of care about what they can do with it. So it's really important to have that. The other thing is that you want to put the boring parts into the library. This is more practical. What we did for the middle schoolers was that we took a lot of the code that the high schoolers would write, but we just turned that into a library and just gave a few easier controls, like look for line and check, like we wrote functions like check for line underneath and go forward and those types of things that really made it easier. And you didn't have to worry about the students didn't have to worry about boilerplate. Part of this also is the test. You really want to make sure all your lessons are tested, because you don't want things to break in the middle of a lesson, because you only have so much time, and you really need that momentum, because if students sort of fall out of their interest, it can be sometimes hard to bring them back, and you don't want to be flustered in the middle of your lecture when you're demoing some code. Something we found that's actually pretty useful for this is to just take videos of the code and put them in your keynote instead of doing it live, and then you can debug more individually with the students, because if you're working with the students more one-on-one in their problems, it won't take away from the rest of the class. And another thing is that you want to control the environment. By that I mean is that you want to control the Python environment. I think Python pretty infamously has some challenges around package management, that kind of stuff, and that can take away a lot of time if you're trying to debug that. So what we did is we used our own laptops. We installed Ubuntu on a bunch of old laptops that were donated by some company, I think, and that was really, really helpful, because it allowed us to just not worry about like, is Anaconda not going to install your iteration? Okay. Since then, I've been teaching with KT-Byte. It's a computer science academy based in Lexington. They have classes that range from elementary school to college level, including a lot of competitive programming courses. Most of the classes are delivered via synchronous lectures. Before COVID, there used to be some more online stuff, but since COVID, it's mainly, I think they're fully virtual. They have students from across the world, but mostly in America and China. I was a teacher assistant for courses ranging from an intro to coding via Java to competitive programming courses. And then this last summer, I actually was designing my own courses. And the one that ran was a Python class. It was very much club style. It was more open-ended than one where every single lecture from start to beginning is choreographed and curriculum is designed. It's much more of a dialogue between the students and myself. And what we did for this one is we did the first two classes were about an introduction to Python, because the prerequisite was to have a little bit of Java experience. And then the main project that the students and I settled on was to almost recreate a brick breaker type game using Pyglit, which is a graphics library in Python that's pretty neat. I think we also did some data visualization stuff. We spent a day doing some web stuff with Flask, which was really fun. But the big thing was this brick breaker game that was pretty much, that was very student directed and student programming led. What I took away from this is that you want to filter and place students accurately for both the success of the student and the classroom. What I mean by this is that you want to set good prerequisites for different classes, because otherwise there might be occasional times where students are mismatched and are too advanced or are not advanced enough, and it can lead to both the class and the students sort of losing momentum and losing energy. So that's something that's very important. Another thing that I found is homework. KT-Byte, as you get more advanced, does assign a fair amount of homework. For the competitive programming class, there's about 3-4 hours a week actually. And and it's pretty valuable, but for younger students, it's not that valuable. Maybe a little, what I found is that giving a little bit of like syntax repetition and that kind of stuff can be very good, but going too far beyond that and making them do exercise on their own, when like elementary school and middle school students aren't at that level, can be harmful because it's just they'll get lost, they'll get frustrated, and that's just not a great experience. Flexibility is good in moderation, since this is more of a part-time, like a week classes once a week for like an hour or two. It's good to have some flexibility. People are busy, students are busy, parents get busy. So you need some flexibility, but you don't want students to fall behind. And because if they fall behind again, it distracts from the momentum. What I found that was a good idea is that give students some leeway, maybe do some one-on-one with some students, make a plan for them to get back on track. But if students really aren't on track, I'd say it's okay to move them to the next class and move them to a different class. This is more so for like extracurricular computer science education in college or in a high school like class. This probably isn't the best strategy. The other thing that I found similar to KT Book is that you want to get students interested quickly, especially for younger students, because they don't care that much about what creating like data pipelines. They aren't focused on that, and they don't not to say they don't I mean, I'll say that they don't appreciate the use of Python in more like academic situations. So get them to the interesting parts fast, do exercises, give them little like games they can finish, give them little exercises where they see their code doing something valuable. Often I found that creating shells and tests that have visual feedback is really helpful. And the other thing is, for remote teaching, you need a really good setup. I was working with by setup I mean like physical computer setup. You should have multiple monitors. You need a good mic. You need a good camera. At the beginning of the pandemic, and some other instructors just did not have the necessary setup, and that did really impact the classroom. So what are my final takeaways, and what sort of have I learned throughout my 4 years of teaching? Simply put, I do believe Python is the best language for teaching. I've taught Python, JavaScript, Java, a few others here and there, but what I saw is that Python has the best ratio of ease of use over amount of gotchas. So while Python does have some parts that can catch you off guard if you're not fully ready for it, mainly with type coercion I found with students, it's still really good to start. And the other thing I found that's really good about it is that it enforces a decent amount of code cleanliness, because white space is syntax. Because I found that in Java and JavaScript, sometimes code became a mess and students would have a hard time reading their own code back. Another thing that I found is that teaching a language is not the same as teaching computer science or programming. Basically, for the Python club, the requirement is that students know what computer science concepts like variables, loops, functions, so that kind of basic stuff. Because teaching the syntax for that in a new language is just not the same as teaching that foundationally. And it's very important to figure out what kind of class you are teaching. If you're teaching CS or if you are teaching syntax, because that's going to change how you approach lessons. That's going to change how you approach pacing. That's going to change a lot of things. When I was a sophomore, I had a computer science class where my teacher gave us the quote, "Computer science is not about computers any more than astronomy is about telescopes." And I only really found that to be true to myself when I started teaching myself. Something else is that I believe in person. I think when teaching, there's an energy of being around your students and around other teachers and TAs, where you can better understand what's going on and what people's thought processes are. And if they're lost, or if they're really getting the material, that's much harder to do online. I also think for younger students, they get less distracted in person, and also there's a in-class energy that will funnel the class in a correct direction. again, I think this is getting repetitive, but I really want to drill this point in. It's that the labs and exercise are king, but students do need some context for what's going on. And by that, I mean, students really, especially as this is about middle schoolers mainly, like middle school, even high schoolers and elementary school students, they really need to see the code doing something, because otherwise they'll get bored. Even the most motivated student is going to fall behind. This isn't like a college class where people more or less have motivation to be there inherently, and you can do like a few months of like theory and like screed out mathematics before getting a single line of code. That's just not something that works in this context. The biggest thing that I found, the big two determinants of performance that I found are motivation, discipline, and aptitude. Basically, if a student is motivated to do well, they will do well. But I found that discipline, making sure they do the homework, making sure they are paying attention in class, is also very valuable. And I found that aptitude, while not that important, I've actually found, I have seen that it does play a role at the end of the day. A little anecdote I'll give before we go. The best performing students from Beaverworks were actually these twins. They were much younger than everybody, but they were always the first to understand stuff because they were always working together. They were asking questions. They were very much encouraging. They were very much ready to soak up the material. And the other thing is that the youngest student in my in one of my KT by classes that I was teaching was also very successful because of their motivation. Yeah. So that's the end of my speech. Let me know if you have any questions.
All right, thank you very much, Daniel. I'm very pleased for your students. I think they're very lucky to have you at the front of the room. I think we have time for maybe one question because I do want to make sure we get to our last talk. So Matt has his hand up.
Yeah, hi. Great talk, Daniel. Really impressed. Have you worked with or have you taught a Scratch at all?
I've worked with Scratch a little bit and I taught it a little bit. What I've actually found is that Scratch can be very useful sometimes, but sometimes the visual aspect and it can slow students down in not a great way, and sometimes it can be even more harmful, even though the ease of use is easier than a written programming language. The limited functionality can be a little not like harmful to progress. What I do think though is that visual and block-based programming is really good with hardware and like Node-RED and stuff like that, because again, it's all about students feeling like they're progressing, and sort of when they see hardware light up, it's very beneficial. And for that, sometimes line-based programming can be rough for the complexity of hardware programming.
Thank you. That's
great.
great.
Hand up. Is it a quick? Oh, sorry, Matt. Go ahead.
No, that's great.
I typed in the chat. I just said that there's some neat.
Oh, I see.
If you think it's cool to help out with high school kids and stuff like that, and you're inspired by everything Daniel said, which was very inspiring, volunteer with the local robotics group at your high school. You'll write some Python code and get to play with robots.
Nice. All right, great. Thank you very much, Daniel. Flav, are you ready? I'm not sure how to pronounce.
Flav, yeah.
Flav, are you ready for our last talk?
Yeah. I love how it turned out that multiple presentations have to do with open source, and I'm yet another one of them. And I'm hopefully I will complement what has already been said.
Hopefully you won't contradict.
Right. However, yeah, I certainly don't like it.
Okay. Cool.
Hi everyone. My name is Flaviu. I'm a senior software engineer at Dino Therapeutics, and today I'm going to talk to you about going from 0 to 1 in open source. So often when you look up information about the challenges of open source software, a lot of stuff comes up that has to do with maintenance, updates, and contributions, for example. However, these kind of struck me as aspects that fall into this bucket of going from 1 to 100. Whereas in this talk, I'd like to talk about going from 0 to 1. So how do you even get started? In my experience so far, I've heard many developers claim they don't have the necessary experience to contribute to open source. And this is a sentiment that I've heard expressed particularly in this regime of open sourcing a piece of software that someone contributed to in a company setting. So in this context, how do we go from 0 to 1? one of the most powerful things about software is the amount of freedom you have to create something out of almost completely nothing. You can identify a problem, identify the context of the problem, shop around the value of providing a solution to that problem. And once you validate it, you can start ideating, building, and testing specific solutions to that specific problem. And you may end up using at first different open source solutions as a starting point to provide some immediate value. That is, until you hit some roadblock. Maybe some open source solution just doesn't solve the problem, it solves the wrong problem, or it solves the problem at hand in just some non-optimal manner. So naturally you decide to write your own solution, you start building, and then lo and behold, after a bit of time, your users express that the solution you provided them with is so much better than existing ones. So you have an idea, what if you open source this to your solution to this specific problem that you're faced with? You gain positive feedback, you've done something right, you decide to contribute it to the world the same way that the initial solutions, albeit not optimal, were accessible by you because they were open source. So you get excited, it might be the first opportunity you have to contribute to something in the open source world. So you propose the idea and you shop around the thought, and then you start hitting barriers. You start asking yourself, is this really good enough? Maybe one of your managers is concerned that this is free expertise that the company's given away. What if your competitive edge will diminish as a consequence of the open source exercise? Perhaps the legal department is challenging your idea by asking questions about intellectual property issues. So how do you overcome this? With every single such barrier, either internal, which is you questioning yourself, or external, which is someone challenging your idea, you get more and more discouraged and you end up not doing anything. Now, of course, that's exactly what you want to avoid. What you probably want is to have the support, to feel empowered, that you can take something that you created, something of value, and share it with the world. So irrespective of your level of experience, how do you find the level of support that allows you to feel empowered? I went through a similar process at Dino Therapeutics. The company adopted Argo Workflows as its internal workflow engine. Briefly, it's a system that allows one to submit highly parallel jobs on Kubernetes, which is a container execution engine, like Docker at planetary scale, in case you may not be very familiar. And at the time, there were two main open source tools available for constructing and submitting Argo workflows specifically. At Dino, we have a team of amazing scientists who want to focus on science, not the engineering intricacies of constructing and submitting workflows. So at Dino, the process was as follows. We found a problem, we understood the context, we tried existing solutions to deliver immediate value and noticed they didn't work for us. We constructed our own solution, and then we wanted to open source it. So of course, we had to address the questions. Is it really good enough? And well, it depends. Maybe the project is highly specialized. You're concerned that you're concerned about that. You don't plan to release it, or you may want to open source it because your solution operates in a highly specialized context. And there are many solutions to problems out there in open source. And now this question of is it really good enough? Maybe reminiscent of school years. Maybe in the past, if you had a question about a topic, it's likely that someone else had it as well. And I believe James said this in his presentation as well. In this context, if your problem had sufficient importance that you had the justification to invest the time necessary for coming up with a solution, it will likely help someone else as well. In our example, Hera was a solution to a problem of accessibility to an open source project, to a popular open source project. Argo has more than 10,000 stars, and it's a great engine for Kubernetes, and there's a community appetite for using it, but it was challenging to access it using Python, which was the primary motivation for the solution. On the free expertise topic, maybe one of your managers is concerned that this is free expertise the company is giving away. This is where you have to be slightly strategic. And I would first encourage you to not think about this as a convince your manager exercise. You should really attempt to demonstrate the value of the open sourcing endeavor using terminology that denotes value for your organization specifically. How does this exercise help the organization? Can you position your justifications in terms of return on investment in the recruiting regime, perhaps? Can you find a way to use the open sourcing endeavor to attract engineers to the organization? And these are tough questions, particularly for people who may not be experienced. So what do you do in that case? Well, in short, you try to find allies. Reach out to experienced engineers first for feedback on the project and the thought of open sourcing it, And second, ask for help on identifying strategic presentation opportunities for making a case to your managers, and if possible, invite your allies in the same room in which the conversation with the manager is taking place. The key outcome is to gather support for your pursuit from more experienced engineers who may have an easier time constructing a story around the why and the value for the organization in supporting your open source exercise. In Hera's case, the justification was primarily focused on how Dino derived value from using Argo, how the organization did not identify success using existing solutions, how open source projects tend to attract talent, and how the organization can support independent contributors' growth by providing the necessary support for this project. And lastly, maybe the legal department is challenging you in the intellectual property realm. And this is highly context dependent, and it's significantly dependent on the type of solution you provided. Is your solution a general representation of some set of atomic units that kind of hold true in almost any context? Can you use your code without conveying any aspect of your organization? Can you take this project and inject it someplace else and welcome another organization's context into it? And if you answer yes to most of these types of questions, you should construct a story that does not touch upon the code. Because remember, your audience is not software engineers, so don't use things like strings and functions and classes or anything else of that kind. You just have to do it using a gentle approach, because you want to focus on explaining how the project is not context dependent and it can be used in almost any organization that has the problem that you had. Hera was a unique opportunity in the sense that it was truly not context dependent. One can inject any code, any Python code specifically into Hera for remote execution on a Kubernetes cluster through Argo without any knowledge of anything Dino related, which alleviated the intellectual property concerns that were brought up at the beginning. So you check the boxes, you overcome the internal turmoil by seeking help from others. You have your manager support the open source project. The legal department understand there are no intellectual property risks. What's the next step? I initially wanted to talk briefly about kind of the high level fundamentals of Python packaging, but then I changed my slide and I decided to skip it and just encourage you to watch Patricio's presentation, because he actually did a great job at presenting the fundamentals of it. And he also mentioned this link.
That's amazing.
Exactly. And I also linked here the packaging Python or documentation because it's a great resource, as Patricia said. And I encourage you to check it out if you plan to open source something. All right, so we talked about how you can identify specific problems in our organization. We talked about understanding the context and attempting an initial set of already accessible solutions to demonstrate some value. We discussed how we can provide a solution that may end up solving a problem in some original way, which can motivate us to pursue open sourcing that solution. And of course, we talked about the challenges associated with open sourcing a package, which range from internal conflict to managerial approvals and intellectual property concerns, and how we can overcome some of them. And that was it. I encourage you to watch Patricia's presentation about Python packaging because it was great. My name is Flaviu again. I'm a senior software engineer at Dino. These are the platforms you can find me on. And I'm always happy to chat about anything software, open source, or biology.
Great, thanks. James mentions in Slack that for choosing a license, there's chooselicense.com, which is a website that helps you navigate that thicket. I'll mention that for convincing people that it's a good idea to open source a tool that you depend on, there's the possibility that you will get other people helping you to make it a better tool that you depend on. And that's sort of free work for your organization. There's no guarantee that that'll actually pan out that way, but you certainly won't get the free help if you keep the tool private to yourself. Does anyone have a question for Flav? I still don't know. You told me and I still don't know how to say it.
It's Flav, thanks Ned.
Does anyone have a question or comment besides the two that we've already had? If not, we've come to the exact minute we were supposed to come to, which is very impressive. Remember, we're going to be doing this again in May. I think we already might have 3 possibilities lined up, but if you were inspired by any of these talks to do a talk, please keep an eye out for that announcement. James, what's up?
Flav, yeah, great presentation. I wanted to ask you, you mentioned the having the discussion with your employer in a professional context to open source something. What did that story look like for you at your employer? Was there kind of that back and forth? Was it a problem? Did you have to, exclude certain licenses, things like that, when deciding to make your tool open source?
I think it was very, like, as I initially outlined it, I had a bunch of questions for myself, like asking myself, is this actually a problem? And then there was the management chat with the initial idea of open sourcing it, and that was a bit of back and forth to really understand whether this will give away any sort of intellectual property. And then there was the discussion about licenses, mostly with the legal department. And I wouldn't say that there were any restrictions. We just wanted to pick a license that was, we actually open sourced this project in collaboration with the maintainers of Argo, and they had to kind of approve the license themselves. So we had to find a happy medium and ended up choosing MIT because it satisfied both parties' requirements.
All right.
Cheers.
If you have any inkling at all that you might want to do a presentation, but you need some help, either picking the topic or whittling it down or just general encouragement, get in touch with us on Slack. I would be happy to do that. One of the presenters tonight talked to me on Slack about possible topics, and we chose one together. It worked out great. So I'm available. I know James and Brian have both also said, and John have also said that they would be willing to help people. So, choose which of the four of us you like better and get in touch with us on Slack, and we'll help you find a talk. Collaboration night is a week from tomorrow. Office hour every Monday at noon Eastern time. And we're going to do another one of these in May. And get in touch with me on Slack if you want a PyCharm license. And that's it, everyone. Thanks for coming.
Thanks for facilitating, Ned. Bye, everyone.
Thank you.
Thanks, everyone. Thanks, Ned.